Hello YouTube, welcome to the last video of the series. So this is the fifth video of the series. I hope this is the last one. So in this video we'll talk about the workflow tool that I showed you earlier. So here is the workflow tool. I'll just replace the ANSYS Fluent with ANSYS Icepak. Okay, so here we cannot use the same geometry file for the ANSYS Icepak because Icepak has specific settings for geometry. So we'll right click on the geometry and select duplicate. Then we'll bring an Icepak module right here. Then you'll select edit geometry in design modeler to do some simplifications in the design modeler before connecting it to the ANSYS Icepak. Okay, first you need to select domains and right click hide body. Then for this one, right click hide the PCB, and then you need to unite the PCB, the copper parts. So we need to go here and select box, this one, hold down control key and this one, and go to the here we'll select boolean and click apply and rename it to unite. Select generate. So then we can select this and right click hide body, and then select this one, hold down control key and select this part and go to create a boolean, apply geometry, rename it to unite2, and then right click and generate. Then right click hide this body, then select the other track, then go to create and boolean, apply geometry, rename it to unite3, okay, and right click and generate. So now we have, if I right click and select show all bodies, so here you can see that we reduced everything to 5 bodies, 3 tracks and a board and the air chamber. So next thing we need to do, we need to select the air chamber and go to tools and electronics, simplify, apply geometry, and I will select level 0 simplification and right click generate. Okay, so now this is a block over here, and then you can right click and okay, so I need to go here, select this one and hide body. Then for the other parts I need to do the same thing. I need to go to tools, electronics, simplify, apply geometry and select let's say level 1. So generate. This is the other simplification that we need to make. Then select the other part and go to tools, electronics, simplify, apply geometry, apply geometry, and then select level 1. Then right click and generate. For the next one, okay, right click hide body. Then for this one we need to go to tools, electronic simplify, and apply geometry, and for we need to select level 3 CAD object. So generate, that is it. Then for this one, tools, electronic simplify, apply geometry, and select CAD object, generate. That's it. And then for this one, the last one, apply geometry and select CAD object and select generate. Now we have everything that we need for the ANSYS Icepak. So we'll save project. Then we'll go to ANSYS Workbench. Saving project is in progress. Saving is done, so we need to drag this geometry to set up in ANSYS Icepak, and also the solution of the ANSYS Maxwell to the setup in the Icepak. Then we can close Design Modeler, and we can start ANSYS Icepak. ANSYS Icepak is started, so we can go here and see our model cabinet. So I will disable the names of the object. Let's see which one is the... So we will delete the air chamber because we have the cabinet here already. Okay, then this is our low loss. Low loss track. Update done, and this is our high loss track. This is our middle track, and this is our board. So for the cabinet, if we double click on it to edit the cabinet, and we select the minimum X to be opening, and for max X to be opening as well. So for the opening, we'll specify the temperature, ambient temperature, and not the radiation. X velocity, so it's gonna be 0.2 meters per second. Update done. and for the outflow. So we'll select the static pressure, update done, and update done for the cabinet. And also we need to go to file and EM mapping. Set volumetric heat loss. So we'll select the low loss, high loss, and middle. Select this one and select 20 kilohertz for the frequency and select accept. So it will import the losses from ANSYS Maxwell. So for the low loss, for the properties, for the material, we will select CU pure, update done, and for high loss as well we'll select CU pure, done, update, and for the middle trace as well CU pure, update done, and for the board we'll go to FR4 update done. Then for the cabinet, it's going to be air. Okay, then we need to go here for the basic parameters. Turn off your radiation and laminar flow. Ambient temperature is going to be 26.85 degrees Celsius. Radiation temperature, we don't need that. Default materials. For the fluid is air, and it's going to be steady. Okay, accept. Then for the solution settings, basic parameters, number of iterations, let's say 1000, and -9. Accept. The parallel settings, parallel, and number of CPUs in parallel 4. For the advanced settings, we'll set it as default. Okay, the last thing is meshing. So we'll go for meshing, and we'll go for the local and object parameters. We'll activate the object parameters and then select edit parameters. Then we'll select cabinet and we'll use the pre-object parameters. Then we'll activate all of these directions, and we'll put 200 mesh for this one, 200 for this one, and 50, 50, and 20, and 20 for this one. So for the board, for the high loss, we'll activate this 4, and we'll select 200 20, and 2. For low loss, we'll do the same. 222. And then for the middle, we'll activate this and we'll specify 280 and 22. Then for the board, we'll activate these 4 and we'll select 200, 100, and 2. And also for this one, for the inlet and outlet, we'll specify 150 and 40, and for this one as well, 150 and 40. Done. And we'll click generate to generate mesh for this one, and then we'll come back when the meshing is completed. So the mesh generation is completed, and you can see that we have around 2 million number of mesh elements. So if I try to display mesh for our geometry and select this, you can see that our mesh is quite accurate. So we can now start our simulation. So I'll check the model, no problems were found, then I can run the simulation to see what happens. So we'll come back when the simulation is converged. Our simulation is converged in the ANSYS Icepak, so you can click done, and this is the convergence plot that you can see here, and our residuals are all lower than 1 e to the minus 9. Okay, we can select done. So in order to see the temperature plot across the geometry, we can select these objects and inlet and outlet and right click on all of them and go to create object faces combined. Then it will give us the temperature contours and the temperature contours on our geometry. So the maximum temperature, if you can see here, is around 421 degrees Celsius, which is very similar and close to the results of the ANSYS Fluent that we got. So we can say that these two software packages are performing as the results are exactly the same, so they are performing at the same accuracy because they are using the same solver. So this is it, and if we go to the ANSYS workbench over here, so we have now simulated the temperature rise using ANSYS Fluent and ANSYS Icepak. So the next step is using ANSYS Mechanical to do the board deformation analysis. So I'm not gonna go to details in that one because every single step is exactly the same as we did for this module over here. The only difference is that you will take the body temperature map from the ANSYS Icepak instead of the ANSYS Fluent. So if I select the ANSYS structure over here, so we can connect this geometry to this one and then the solution to the setup. Then you can define the material and the engineering data as we did for this one. Then you can go to model and perform the analysis. I will leave that one for you guys to have an exercise, because it's exactly the same as we did for the for this D module. So for the F module you can do it by yourself. So let me know if you have any questions or comments in the comment sections down below, and please subscribe and spread out the channel if you like the video and the content. So till the next project and another simulation package, we'll see you soon in the next packages. Bye.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.